All right, so in this one, we're looking at basic stoichiometry. So there's kind of two parts to this. We're going to look at balancing reactions and then doing grams to grams conversion. So in balancing, then we just have to kind of relate the number. So we need all the atoms on the reactant side to match all the atoms on the product side. And when you have a nice simple one like this, it's kind of easy. So the thing is, you just have to start somewhere. So like if I were to start and I would start with one Na here. And so I have one Na on the left side. So I have one Na on the right side. And then now the CLs. So I have one Cl on the right side. I would need one Cl on the left side. And then the last thing is the hydrogen. Since I have one, and we can see that because it comes in sets in two, there's a problem, there's a fraction. So I come back and I just double everything and then continue. And now we have two hydrogens, so only need one of these. And so that's how I would get to a scenario like this. If in doing the reactions, then so if we try to do the same thing with this, then you can see just summing up the lead on the left side and the right side, we do the same thing. However, there's some tricks to make it easier. So you can see that the sulfate is a polyatomic ion. So instead of breaking up the oxygen and sulfur, if we actually just make one that has a sulfate, it'll make it much easier to do. And so again, kind of starting, I would start with the ugliest one. And so you might start with this one. And so let's just say we have one lead hydroxide. And so that means I have one here. And then it's coming with two sulfates. So I would put a two here. So two sulfates. And then the last thing then is the hydrogens. And so we have to count then the hydroxides. So we have uh, and we have four here hydroxides. So we need, and we have four hydrogens here. That would lead to four waters over here. And so you can see down here, this is what it would give you in that. So you can either break them up individual atoms, or if you recognize those polyatomic ions, it makes it much easier to do. So going on, then the next thing that we look at is the molar mass, adding up the molar mass. So hopefully you know that. If not, it's relatively easy. If you have H2O, you just have two hydrogens and one oxygen. So we have two hydrogens, one oxygen, and we just have the AMU for the different ones. And so we can add that up and get 18 grams per mole. And the meaning of it is that that gives us our conversion between when we measure grams and we go from moles. And so we get problems like this. If 200 grams of propane is burned, how many grams of water is produced? So we're going to go from this to this over here. And so the steps to this are you always go from grams to moles, and then you go from moles of one thing to moles of another. And so moles of the hydrocarbon to that. And then lastly, because it wants to go to grams, you have this. So another view of that would be here. So if we look at uh, the balanced equation, what it's saying is that we get these equalities, right? One of these is equal to three of these, or two, or so on. And we can do it either way. And now we can get to the classic dimensional analysis you learned in the first one. If we start with a given amount of this, and we can relate it then to how many moles of something else are produced through that mole to mole ratio. And so what we get then in the classic kind of problem is this conversion where you're going to, so we're going to then convert from grams of nitric acid to grams of barium nitrate. So we have grams to moles, and this is just involves a molar mass. So we have grams of nitrate. We need to put it on the bottom, and we put moles of nitrate on top. Then we're going to go from moles of nitrate to moles of barium nitrate. This number always comes from the balanced equation, that mole to mole ratio. And then lastly, we go from moles of barium back to grams of barium nitrate. And again, just like over here, moles to grams is just the molar mass. It comes from the periodic table. So those are the types of problems you'll find in this problem set.